Here are the rest of the questions you sent. I think a lot of them, from what I could tell from the answers you gave, were mostly just like little sign issues. So let's go ahead and work through it though, either way, just so we can see. So I like to draw a line to separate the two sides, and so you want to distribute if there's any of that that needs to happen. So let's see, this will be 4x plus 4 plus 3, and then greater than or equal to 3x plus 12. And so if we have any like terms, we'll combine them, and we can on the left. Let's see, that'll become a plus 7 when we combine the 4 and the 3. And then from here, you're just kind of solving for x like you would in a normal equation, except that we have an inequality. So I'm going to subtract 3x from both sides. And let's see, that'll leave us with x plus 7 is greater than or equal to 12. And then we'll go ahead and subtract by 7 on both sides. And so we'll get x is greater than or equal to 5. And so we're talking about values larger than 5 or equal to 5. So we got to use a bracket to include 5 and then go to infinity there. So that's our first one. So you got a couple more. I think they're pretty similar. So this one, let's see, we're going to go ahead and distribute the 4. So we'll get 36 minus 8x is greater than or equal to 20 minus 6x. Okay, now there's a couple different ways you can approach this. What I'm gonna do is I'm gonna move the x over to the left side and I'll show you why in a second. So sometimes I would maybe have done it the other way, but let's see. So we're gonna have 36 and then that'll give me a minus 2x is greater than or equal to 20. And then I'm going to subtract 36 from both sides. And so I still have the negative, or the minus becomes negative 2x is greater than or equal to 20 take away 36 would be negative 16. Okay, this is where a lot of times students will mix up their signs. It's right, or well, maybe not even their signs, but what we have to do here is when you divide both sides by a negative, it causes the inequality to reverse directions. So what's going to happen here is this will be x, but this will turn into a less than or equal to, and then negative 16 divided by negative 2 is a positive 8. So my solution its values less than or equal to 8. So that's going to be from negative infinity to 8, and then we'll bracket that 8 in. So that's something that we'll see happen sometimes with signs. Um, Sometimes, you could have solved it by adding 8x to both sides, and then what would have happened, you would not have had that issue of having to reverse the inequality sign, but then your answer would have looked like this. It would have been 8 is greater than or equal to x. And so it would have looked like that. And sometimes that throws students off also. But what you want to realize is those two things, they really are the exact same thing. Because it's good to be able to read the inequalities like x is less than or equal to 8. But also that, if you read it from right to left, it also is saying x is less than or equal to 8. So just thought I'd point that out. All right, let's see. Here's another one pretty similar to the previous two. So you have to distribute the negatives. So we're going to get 3 take away x take away 6 is greater than or equal to 5 minus 9x. And so the 3 take away 6, that'll be a negative 3. And then we have a minus x is greater than or equal to 5 minus 9x. And then I would think probably adding 9x to both sides would probably be our best move here. And so that'll leave us with negative 3 plus 8x, because you had a negative 1, but we add 9 to it, so it becomes a positive 8x. And then that'll be greater than or equal to, that'll cancel out, that'll be 5. And then we're going to go ahead and add 3 to both sides. So we're going to get 8x is greater than or equal to 8. And then we're going to divide by 8 on both sides. And x is greater than or equal to 1. So greater than or equal to 1. So 1 to infinity. There we are. Okay, I think I have one more in this. I think it's from the next sections, the absolute value ones. Okay, so first you want to isolate the absolute values. So we're going to subtract 7 from both sides. So we're going to get the absolute value of 6x minus 1 needs to equal 0. Well, whenever this happens, you're only going to actually get one solution. Typically, you had to figure out what would make this equal positive or negative, whatever you had on the right side, but 0 is neutral. Um, so you just really need to solve that. You just need to figure out what makes this equal 0, and we should be good. So let's see, we'll add 1, and then we'll get 6x equals 1, and then we'll divide by 6, and so we get x equals 1 over 6. Okay, and so I just noticed the question I worked out was not the one that you actually submitted. So let's look at that one. Sorry about that. So let's start by subtracting 6 from both sides. So we'll get the absolute value of x plus 2 equals negative 1. And so the absolute value, the whole idea of the absolute value is that you're always going to get a positive result, or 0. 0 is okay also. But whenever you take the absolute value of something, it always comes back 0 or positive. And so see, this is actually going to be impossible right here. It can't equal negative 1. And so that's why this one's going to be no solution. So yeah, absolute value always comes back as a positive number, always going to be or 0. I don't want to forget 0. But it can't be negative because it's the distance from 0, and distance can never be measured as being negative, even if you're looking at like -2 or whatever. But the distance when you take the absolute value of -2 would come back actually as +2, and so can't be negative there. So all right, well, I hope that helps clarify some stuff.